Okay, this is the second time I'm doing this video. I don't know what happened the first time, but we're gonna barrel through this. A central angle is an angle with the vertex at the center of the circle, and its two sides are radii. Remember, one radii? No, it's called radius. The sum of all central angles in a circle is 360. So if you put a bunch of central angles together, they add up to 360. An example of a central angle is angle ABC, or it could be angle CBA. As long as the B is in the center, we're good. The degree of the arc formed by the endpoints of a central angle is equal. So this arc right here is going to be equal to this angle. Okay? So the arc AC is 84 because this angle is 84. To find this arc, you do 360 minus the 84 to get 276. All right, let's go down to problem number 3. So problem number 3, this right here is a 90 degrees, which makes this arc $90. If that's 90 degrees, so is that one, which makes this 90 degrees. So first things first, this right here is 90 degrees. I'm not sure where it is. That's interesting. Okay, we'll just write it in here. Okay. And then for FD, okay, for FD, it's going to be this 90 right here. This 90 right here, plus this 34. And that's how we get the 124. Okay. For DCF, so we're going to go DCF. Okay, DCF. We're going to do 360 minus the 24. So this right here is the 124. So if I just subtract 360 by 124, I get the 236. Okay. And then to find the GDF, so we're going to go from here, G, all the way to D, and then to the F, starting here, going all the way around, and stopping here. Okay. We have 90 in here, we have another 90 here, and we have another 90 there. And then we have our 34 here. So 180 plus 90 plus 34 equals the 304. So looking at number 9, again we have the red box, which means 90, and all the central angles add up to 360. So that means the arcs, if we add up all the arcs and equal it to 360, we can solve for x. So I want you to pause the video right now and solve for x. Go. Hopefully you solved for x and got that. By doing that, you can put the 7 there. And then to find all the other arcs out right now, we can just do this. We can do 8 times the 7. So for VW, that doesn't have one. Let's do 21 times the 7. And then this one is 10 times. So by plugging all those in, you can find that WX, so from here down to there, is going to be your ooh, that's really bad. Your 135 degrees. Your YW is going to be your 146. Your YX is going to be your 79. And your 3XW is going to be your 304. Okay? Arc length. The length of an arc is a portion of the circumference, so it's the length. So the formula is going to be the length is going to equal a measure of the arc over 360 times the circumference. Now, the circumference can either be 2 pi r, or circumference could be pi d. Okay? So let's look at number 10. So EB is 15. So this guy right here is 15. Find the length of CD, sorry. That's what we want to find right there. Okay. What do we know about all the radii in a circle? All of them are equal, which means that this is 15, that's 15, that's 15. Okay. What do we know about the arc length? Well, because it gives us this 68, we know this is 68. Okay. We want to know what this guy over here is. How are we going to figure that out? Well, this is the diameter. So this can be 180 minus 68, which ends up being 112. So this is how you figure this out. The length is equal to the measure of the arc, which we want is CD over 360 times. They only give us the radius, so we have to use the 2 pi r. And you can put this over 1. So we have 112 divided by 360 times 2 pi r. Oops. 2 times 15 pi over 1. Okay, this becomes 30, which means 30 will go into that. Well, I could do this, cross off the zeros. 3 will go into this once. 3 will go into that 12 times. So now I have 112 pi over 12, which approximately gives me 29.32 centimeters. Okay, so congruent chords and arcs. Remember, AB here and CD are chords. Two chords are congruent if and only if their corresponding arcs are congruent. So AB is congruent to CD, the measure of arc AB is congruent to the measure of arc CD. They are equidistant. Try that one again. From the center, which means that AB is congruent to CD, EF is congruent to EG. If a diameter or radius is perpendicular to a chord, then it bisects bisects the chord and its arc. All right, so with all of that, let's look at number 1. So knowing that these markings tell us that the chords are congruent, we can then just do this. Because the chords are congruent, the arcs are congruent. We solve down, we get x equals 13. If we look at number 4 here, it says that the chords are congruent again. Therefore, we can make the arcs congruent. And if we solve down, we get x equals 13. But I'm not done. It wants to know what the measure of arc RS is. So the measure of arc RS is equal to 11 times the 13 minus the 72, which ends up being 71. So hopefully this works. You guys are going to be able to do the work. Make sure you guys pay attention to what you're doing, follow detail, ask questions, work together, and be nice to Mr. Lander. And first period, I hope you were able to recap this and from our lesson on Thursday.